So today we are going to look at solving a system of equations by graphing. So we know what it means to solve by graphing when we just have one line, and that is that every point along that line is a solution. Well, let's look at it when we happen to have two equations. So let's look at the equations. Let's do y equals 3 divided by 2x minus 1. And then let's do y equals 1/4 x plus 4. Okay, if we are going to solve by graphing, what we need to do is to graph each line separately. So I'm going to do that in two different colors. So let's graph this first line, y equals 3/2 x minus 1. We'll graph that in red. So I'm going to start at -1, and I'm going to count up 3 over 2. And I'm just going to keep going 1, 2, 3, 1, 2 in that pattern. I'm even going to go backwards so that from left to right my graph is up 3 over 2, and there's my line. Pretty easy, right? Well, the next step is to graph my next equation. So we're going to graph y equals 1/4 x plus 4. So I'm going to start at +4, and I'm going to count up 1 over 1, 2, 3, 4, and put a dot. And I could repeat that process going the other direction so I could see this line. Looks like this. Now, if each point along the line represents a solution, and I'm trying to figure out what the solution is to both lines at the same time, where do you suppose that I find their solution? Hopefully what you think is we find their solution where they intersect. So we know that the solution to a system of equations is where the lines intersect. And the solution is always written as an ordered pair. So my solution to this system, for this particular system, is the ordered pair. Remember, ordered pairs go x comma y. Would be the ordered pair 4, 5. So let's look at one that's maybe a little bit more challenging. Let's look at, just for the sake of practicing graphing, let's look at the equation y minus 1 equals 1/3 x plus 2. And then let's graph the equation x equals -5. Okay, so remember this equation here, this y minus 1 equals 1/3 x plus 2, is in point-slope form. And remember, point-slope form, it doesn't make sense usually to change it into slope-intercept form. So it is the equation y minus y1 equals m times x minus x1. So the first thing we want to do is identify what the point is. And remember, the point is x1, y1. So in our problem up above, my point is -2, 1. So -2, 1 is the point right here. And then my slope says 1/3. So I'm going to go up 1 over 1, 2, 3. And typically the reason we have something in point-slope form is because it would have a not nice y-intercept, meaning it would be a fraction. And we can see that from this line. So once I get my point and I graph my point, then I just count my slope. So let's graph the line x equals -5. Another tricky one. Remember, x equals -5 is a vertical line, everywhere x is negative 5. Well, negative 5 is here, 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 here. All of these places represent where x is negative 5, which makes up a vertical line. So where is the solution to this system of equations? Well, the solution is where the lines intersect. And where the lines intersect is the ordered pair. And remember, solutions are always ordered pairs. Negative 5, comma 0. Now, if I wanted to check my work on this, I would need to verify that this solution works in both equations, meaning in y minus 1 equals 1/3 x plus 2, that if I plug in 0 for y and negative 5 for x, that I would have a true statement. So I get negative 1 on the left equals 1/3 times negative 5 plus 2 is negative 3. Well, 1/3 of negative 3 is negative 1, and negative 1 equals negative 1. That works. Now, if I check it in my equation x equals negative 5, I don't even have to plug in a y value. I just need to plug in that x value. So is negative 5 equal to negative 5? Well, yeah. So they both work. I know this is a solution to my system of equations.